Here we have a word problem. After passing under a bridge, a whale leaves the water 5 meters past the bridge, jumps through the air and lands in the water again 25 meters after the bridge. Its maximum height was 10 meters. What was the whale's depth when it passed under the bridge? When we solve a problem like this analytically, we must start by defining our axes and our origin. This diagram has been started, and we are defining this as our y-axis, and this as our x-axis. Therefore, the origin will be right here. And with the problem defined this way, we can see that the point where the whale passed under the bridge is the y-intercept of the curve. We are looking for a quadratic equation, and once we find it, we isolate its y-intercept and we have answered the question. There are two different ways of solving this problem. We are going to use the form y equals a, x minus x1, x minus x2. To use this form, I must know my x's and one other point. So let's find those now. My x's are the zeros, 5 and 25. So x1 equals 5. x2 equals 25. My other point will be the vertex. We can see that the vertex has a y-coordinate of 10, but we have to figure out its x-coordinate. We will find the x-coordinate by finding the distance between the two zeros and finding the midpoint of that distance. We'll do this by saying x1 plus x2 over 2, which means 5 plus 25 over 2, which is 30 over 2, or 15. The x-coordinate of my vertex is 15. Therefore, the x-coordinate of the other point that I need to solve with this form is 15. We rewrite the equation with my x1 and my x2 in place. So I'm putting a 5 here and a 25 there. And then we rewrite again, but we replace the x and the y with the x and y coordinates of the other point. So 10 equals a, 15 minus 5, 15 minus 25. Now we will simplify. 15 minus 5 is 10, 15 minus 25 is negative 10, and 10 times negative 10 is negative 100, so we get 10 equals negative 100a. Isolating our a, it will be equal to negative 1/10. Now we write the form of the equation again with our a in its place. Y equals negative 1/10 x minus x1, x minus x2. And we replace our x1 and our x2 again with the x1 and x2 we found in our situation. Y equals negative 1/10 x minus 5, x minus 25. Since we know in this case that the point we're looking for is the y-intercept, and the y-intercept has to be a point where the x-coordinate is 0, we will replace this x with 0 and solve for y. We have to be finding our y-intercept. Y is equal to negative 1/10, 0 minus 5, 0 minus 25. Now we have y equals negative 1/10, 0 minus 5 is negative 5, and 0 minus 25 is negative 25. Multiplying these, negative 5 times negative 25 is 125, and that multiplied by negative 1/10 gives us an answer of negative 12.5. We are ready to answer our question. The whale passed under the bridge at a depth of 12.5 meters. There is another way of solving this problem using a different form for the equation, and that's what we will look at next. The other method we will use to solve this problem uses the form y equals a x minus h squared plus k. To derive the equation this way, we need to know the vertex, which gives us our h and our k, and one other point. The vertex has the x-coordinate unknown and the y-coordinate of 10. So we have to figure out the x-coordinate of the vertex. We find the x-coordinate of the vertex in the same way. We use our zeros 5 and 25. x1 plus x2 over 2 is equal to 5 plus 25 over 2, which is 30 over 2, which is 15. We have our h, the x-coordinate of our vertex. For the other point, we can use either of the zeros. I'm going to use the first zero, which has coordinates 5, 0. We fill in this form of the equation with our h and our k, so we have x minus 15 squared plus 10. And we replace our y and our x with the y and x coordinates of the other point, which is y equals 0, x equals 5. 0 equals a, 5 minus 15 squared plus 10. Now we solve for a. 0 equals a, negative 10 squared plus 10. Negative 10 squared is positive 100, so we have 100a plus 10. If I move 100a to the left of the equal sign, I have negative 100a equals 10, and then isolating my a, it must be equal to 10 divided by negative 100, which is negative 1/10. We take the a we have calculated, and we put it in its place in the form y equals negative 1/10 x minus h squared plus k. And we replace the h and the k again with the x and y coordinates of our vertex. Y equals negative 1/10 x minus 15 squared plus 10. And because the point we are looking for is the y-intercept, and the y-intercept has to have an x-coordinate of 0, we replace this x with a 0. Y equals negative 1/10 0 minus 15 squared plus 10. Simplifying, 0 minus 15 is negative 15, so we have y equals negative 1/10 negative 15 squared plus 10. Negative 15 squared is 225. And negative 1/10 of 225 is negative 22.5. Finally, we combine negative 22.5 plus 10, and we have y equals negative 12.5, which gives us our y-intercept and the answer to the problem. The whale passed under the bridge at 12.5 meters in depth. So as you can see, there were two different ways of solving this problem, depending on which form of the equation we used. The one where we know the vertex and one other point, or the one we showed earlier where we knew both zeros and one other point. This time we had a choice for which form of the equation to use. But depending on what information is given to us in the word problem, we may only have enough information to use this form, or we may have only enough information to use the other form, the type with the two zeros and another point. We have to know both forms of the equation and how to use them so that we are ready for anything we face in an analytical word problem.